Good day. Today, we're going to talk on how to find the domain and range of an inverse function. Remember that if we want to find the domain of the inverse function, we need to have a denominator not equal to 0. It means that we need to solve for the domain for the inverse function and check its denominator. The range of the inverse function is the domain of the original function. Now, here are 4 examples, and you'll be solving the domain and its range of its inverse function. Let me share my whiteboard. For example, let's take example A. We have f of x equals 1 minus 2x. Now, we can find the range of the inverse function by finding the domain of f of x. There's no restriction, so we say that it can be all real numbers, or we say all real numbers. Now, how about its domain? The inverse of this function is f to the negative 1 of x equals 1 minus x over 2. So, since there's no restriction in the denominator, we say that the domain of our inverse function will be x such that x is any real number. Or we say all real numbers. Next, let's have problem example letter B. For example letter B, we have f of x equals 3x squared. There's no restriction in the value of x. So we say that the range of our inverse function will be all real numbers. How about its domain? We need to solve for the inverse of x. And its inverse will be, that's x squared, so square root of, that's 3x, so we'll have x over 3. Now, what will be its domain? Remember that the value of x can never be a negative number. So we say that the value of x should be greater than or equal to 0. Because if the value of x becomes negative, then the value of our radical expression will be imaginary. So we say that the domain of our inverse function will be x such that x is greater than or equal to 0. Please correct the one in your module. Next, let's have letter C. In set C, our f of x is equal to 2x plus 5. So we say that the range of this, there's no restriction, so the range of our inverse function will be the set of real numbers. For the inverse function, the inverse of this will be, let me have a shortcut, that's x minus 5. This is 2x, so that's divided by 2. There's no restriction, so we say that our domain will be the set of real numbers. Now let's go to example letter D. In example letter D, we have f of x plus x minus 10 over 3. The range of our inverse function is the domain of this one. There's no restriction in the denominator, so we say that our range will be the set of all real numbers. While for the domain, we need to solve for its inverse function. We'll have 3x plus 10. There's no restriction, so we still say that its domain is a set of all real numbers. Now, how do we graph our inverse function and its original function? You go back to our lesson in chapter 2.5, and we see that the graph of the inverse is a reflection of the graph of the original function. Y minus x is its axis of symmetry. So for example, the original function is 1 minus 2x, so its inverse is 1 plus x over 2. With that one, this is the axis of symmetry. This is the graph of the original function and the graph of its inverse. On how to do it step by step, you go back to our previous lesson. Next, for 3x squared, this is the graph for 3x squared, and its inverse is this one, the square root of x over 3. For letter C, here's our axis of symmetry. Here's the graph for 2x plus 5, and its inverse is x minus 5 all over 2. This is also the graph. We simply make a table of values for x and y. And for the last one, this is the axis of symmetry. Here's the line for 3x plus 10, the graph, and the other one is x minus 10 over 3. Both are linear functions, that's why both of their graphs are lines.